Hey, welcome back to part 2. In this one, we're going to focus on getting our player's visuals actually working properly, so we're going to make sure that our player can face different directions, can face towards the mouse, and we're going to work on actually drawing the weapon with the player at the same time. This one should teach you a pretty good amount about image control in GameMaker, and obviously gameplay-wise, it's very important for our weapon to be able to face different directions. So yeah, remember, if you're watching as this comes out, this whole series is already on my Patreon right now, so if you get impatient and want to watch the rest of it, go over there. And remember, the project download is also there too, so yeah. But anyways, good luck. Okay, so the first thing that we're going to want to have for our player is the actual sprites that our player has when turning around. I'm going to be using the character that I always use in my videos, which is my little blue character, and they have 4 directional sprites, an up, down, left, and right. But the system will also work with 8 directional sprites, things like that, 16 even if you're a crazy person. It works with any number, so I'll show you how to apply the logic to any number of sprites, not just 4. But what I'm going to do is I'm going to import my sprites from another project really quick. So give me 1 second. Okay, so here you see I have a downwards facing sprite, an upwards facing sprite, a right, and a left. They're all very simple, but I think they get the job done, and they all have an animated walking cycle. I've just hit the play button here on these to just show you that they have full walk cycles, and you see that I have all of their arms out as if they're holding some kind of weapon. So that's kind of the simple way that I'm going to be handling at least how the arms look. I'll be showing you how to turn the weapon 360 degrees in code, and you theoretically could do the same thing with the arms, but I just kind of went for simplicity here first. If you want to copy this, you can. Like I've mentioned before, all these assets are on my Patreon for the highest tier if you want it, as long with the actual project file download with all this code and assets and everything in it. So yeah, but anyways, so I've got my 4 player sprites. And the last thing we want to look at before we move on is where I have set the origin for all of my player sprites. You can see that I've put it at the bottom center, like between the feet of the player, because I like to think of that, the origin point as sort of the grounding point for the player. And this way, whenever we start swapping sprites, you don't get any weird jerkiness. Covered a lot of this in how to make your own RPG video, so I'm not going to go much more in depth. But the last thing to cover that's important is the collision mask here. So you can open up your collision mask tab and go to the manual section, and now you're going to want to have to make your own little edits to your collision mask how you want it to be. Notice I'm editing this in the downwards facing player, and that's because we're only going to edit this one, and we're just going to use the sprite player down as the collision mask for the whole player object. We're not going to have it match the sprite that we're using. We're going to set it to this one specifically. That way, you don't have to, every time the player switches sprite, like you see, like that doesn't fit, this one doesn't fit, and neither does this one. They're all different than this downwards facing one. And if we ever wanted to change it and tweak it a little bit, then we wouldn't have to change all 4 or 8 if you had 8, or even more if you had other stuff. You just have to change this one. And you can make it kind of as tight or as loose as you want. I kind of opted for a little bit bigger box just because I knew that the gun would be pointing out, but you know, to each their own. Do it the way that you want to do it. You can always come back and edit stuff. So anyways, this is how I'm doing it. So the 2 most important things whenever you're doing your sprites is to make sure that they all have a consistent origin point with each other. And for me, the easiest is just between the feet. And I have set the collision mask in my sprite player down to where I think I want the player to run into walls, right? So good. The last thing I'm going to do is I made a new folder called player where you can right click over here and you can create a group, and that'll add a new folder. I just called it player, and I'm putting all my player related stuff in here. You can also right click a group and change its color down here. I change it to blue because my player is blue. And the last thing you can do is you can change the way that your asset tree is organized by going to this sort filter icon right here, clicking it. And by default, I believe it is set to alphabetical order and with the groups showing up above any other assets. I just like to click on custom order, so that way I can drag around things wherever I want them to be, which just so happens it was a very similar format to the other one. But yeah, so now you can start organizing your project how you want to, and now it's time to mess around with the player object again and get the sprites working. So first of all, we can go ahead and change our player's sprite from the blue block to our downwards facing sprite. So that way when we put it in the editor and you see it in the room, see, there we got our player. And on top of that, we can just get rid of the S player. That was just a blue block. So I'm just going to go ahead and right click that and delete it because I don't need it anymore. So let's go into our create event and let's add a new group of variables. And this little group here, I'm going to call sprite control. Now we need to store all of our directional sprites in an array so that we can access them all easily with the same variables. If you've done pretty much any of the other series on my channel, you'll know what I'm talking about. But if not, let me show you how it works. So this is an array. I'm going to call the array Sprite. First, you set it like a normal variable, but what an array is basically a variable that can hold multiple pieces of information in it. So I'm going to do some brackets here, and then inside the brackets, I'm going to put 0. So this is the first entry in our array, and I'm going to set that equal to S player right, whatever my right-facing player is. So that's how you set up an array. It's very simple, and we can add in other entries like this. So Sprite 1, we're going to say equals S player up. So we can add as many entries into an array as we want to. They'll all be accessible by using Sprite and then just changing the entry number. And how we're going to set up our sprites is we're going to think about it on that 360-degree circle graph, right? Where right is 0 degrees, up is 90, left is 180, and down is 270, and then back to 360. So you can see that's why we're going in a clockwise motion with our player. So we're starting with right, then we're going up, which means then we want to go left, and then we want to go down for our last one. Oops. Okay, so this is how you do it with 4 sprites. I'm going to finish talking about this, and then I'll talk about how 8 sprites work in case you have 8. But like I said, we're thinking of this on a 360-degree circle where the right is 0 degrees. So you can think about each of these as a quartered off section of 360 degrees, right? So 1/4 of 360 degrees is 90 degrees because we're using 4 sprites, so we want to divide it up into 4. If you think about these as multipliers, 0 times 90 degrees is 0 degrees, so that would be to the right. 1 times 90 degrees would be upwards, so the sprite player up. 2 times 90 is 180, which is to the left. And 3 times 90 is 270, which is down, and then it just wraps back around. So you can see we're going to be kind of interacting with a direction to find out which sprite that we need to use. So if you were doing something like 8 sprites, then you would want to go just kind of based on divisions of 45 degrees, right? Because 360 divided by 8 is 45 degrees. And so that would probably look something more like, the first entry would still be to the right, but the second entry would be like an upright sprite. And then sprite 2 would be S player up, and then 3 would be up left, 4 would be left, 5 would be down left, 6 would be down, and 7 would be down right. Obviously, I don't have sprites for this, so it didn't fill out for me, but that's how you would do it. So anyways, I'm sticking with 4 directions. You can do either. I would suggest sticking with 4 if you're still a little bit of a beginner, just so you can follow me a little bit more closely, but if you're grasping the concept, then you can do 8. You're just not going to be able to copy me exactly. So anyways, so now we have this array of sprites, and we want to have another variable that we can use to slot into here to figure out which one we need to use. So let's call this face. So real quick, let me just show you how we could use this. So if immediately under all this, we set our sprite index like this. So we're going to set the sprite of our player by setting sprite index equal to, we're going to set it to one of the entries in our sprite array, and we're going to set it to the face. So if face equals 0, whenever we run the game, our sprite should equal sprite 0, which is to the right. So make sure your player is in the room, and let's just see if that works really quick. So I'm gonna run it, and good, my player is facing to the right. So if it's not working for you, just make sure that you set all of your sprites in the correct order. Remember, it starts with the right and goes in counterclockwise motion. So cool, and I think whenever we start the game, in general, I'm gonna want my player to face downwards. I think that makes sense. So for me, that's 3. Again, if you were using like 8 sprites, it would be 6. Whatever. So let's try that again, and yeah, so cool. Okay, so we don't need this line here because we're gonna be setting our sprite index in our step event dynamically. So what we're going to need to do is we're going to need to change our face variable based on some kind of direction that we're going to be facing. Now by the end of this, we're going to want that direction to be the direction that the mouse cursor is from the player, right? The player wants to face the mouse because that's where they'll be aiming a weapon. But so we're not stacking too many things on top of each other at once, we can actually just use our movement direction, which is how most non-twin stick shooters work, where you just face the direction that you're walking. So let's do that first, and then later we can substitute our other aiming direction. So first what I'm going to do is I'm going to do a cool thing right here. I'm going to go under player movement, and I'm going to type pound region, and then I'm going to go under where we moved the player, and type pound end region. This is a nice little organization thing in GameMaker where now we can minimize and maximize this area just to kind of make life easier for us and a little bit cleaner looking. So anyways, let's go under our player movement and add in sprite control. Okay, so let's go down here and I'm going to tab out once just so I can have these little subgroups here. And I'm going to call this set the player sprite. And we already know how to do this. This was the line that we used earlier. So we would say sprite index equals our sprite array at the face entry. So that's what we were doing in the create event over here. Now we just need to change our face variable. And so let's go above where we set our sprite. And now we can say, make sure the player is facing the correct direction. And this is going to be a simple couple lines of code. So we're going to say our face equals, and we want to do some directional input, which for us, we're just going to use the movement direction that we have here first. So let's say movedir, and we need to divide that down and make it fit into these smaller integers here. Remember, like I said, since we're using 4 sprites, these are divided into sections of 90. So we get 0, 1 times 90 degrees, 90, 2 times 90 is 180, 3 times 90 is 270. So we need to divide up our 360 degree directional movement by 90 degrees first. And again, if you were doing 8, you'd need to divide it by 45 degrees because 360 divided by 8 is 45 degrees. It's very important. And so now we're getting closer to what we want, but we can't have any decimals or anything like that. Face has to be either 0, 1, 2, or 3 for 4 directional sprites. So say we're going at 45 degrees. 45 degrees divided by 90 is 0.5, which would be in the middle of right and in the middle of up. But we don't have one of those. And even if you had 8 directions, what if the direction was, say, 20 degrees or something like that? Something that doesn't divide evenly into it. Remember, ultimately, we're going to be using our mouse to aim, and that will have full 360 degree movement. So basically, we just need to take this really small number we have now, and we just need to round it to whatever the nearest actual integer is. So we use the function round, and all this does is it just returns a nice round number from what we have. So in my 4 direction example at 45 degrees, that would just be returning 1, so it would make us go up. If I said we were off by like 20 degrees, 20 divided by 90 is less than half, so it would just round down to 0. So now we have our face returning 0, 1, 2, or 3, but also face can return 4, because what if our angle was, say, 350 degrees? Well, that would ultimately have us rounded up to 360. Because that would be, you know, that would be 3.8, something like that, I don't know. But it would be over 3.5, so it would round up to 4. And we don't have a 4 entry because 4 is going to be the same as 0, right? 360 degrees and 0 degrees are the same thing. So we just want to do one last little thing here, and we'll say if face is equal to 4, then we'll just set face back to being 0. And again, if you're doing 8 directions, then your highest number that you would want would be 7. So you would want to say if our face is equal to 8, then face equals 0. But yeah, so now this will always return our face variable as 0, 1, 2, or 3, which is perfectly in range for the array that we made. And then we're setting the sprite to that correct entry. So let's just test that really quick. And it's working. Okay, hi, hello. This is actually something I completely intended to show off to you, but then just did a really bad job of remembering to do that. So it took me like another hour of recording to actually remember that this was an issue that happens. So you might have noticed that in going in different directions or something like that, maybe sometimes you get like stuck or something like that, like this, right? Like I'm stuck right now. And that is due to the collision masks that I was talking about. So by default, in GameMaker, whenever you have an object, whenever it switches its sprites, its new collision mask matches the one of the sprite. And like I said, we only wanted to edit the player down one just to make our lives easier, but that means that we're gonna have to tell GameMaker that we only want our object player to use the collision mask of sprite player down. Otherwise, you get things like this when your mask indexes don't match each other. So let me show you how to do that real quick. I know this is going to look weird because like I said, I'm actually a good bit farther in the recording process now, but I'm pretty sure this looks exactly the same. So there's 2 ways to do this. First of all, we can go here right above setting our sprite index, and we can just set our mask index in the same way. And what we'd want to do is we would just want to pick the sprite that we want to use. So we could do that by saying S player down, or we could do that by saying Sprite 3 for 4 directional sprites. That's the downward facing one. For 8 directional sprites, that would be Sprite 6. That way, if you did it this way, it would also update anytime you maybe decided to change your sprite array. It would always do it based on the downwards one. So that's one way to do it. Or you can get rid of that and you can actually go over here, right under where you would set the sprite for your player. You can see it has collision mask and it has it automatically checked as same as sprite. But you can click this and open it up, and then you can select whichever sprite you want to use. So I could select sprite player down. And so now, no matter what the sprite index is of the player, it knows to use sprite player down as the collision mask information. So it will always match this. And let's just test that real quick. And cool, no more issues, no more weird stuff happening with all that. Great. And like I said, those are the multiple ways you could do it. Remember, if you set it here, you just need to make sure that if at any point you decide to use different sprites for your player and come up with new ones, you just need to set it correctly here. And same with if you were to set it in the code as sprite player down, you would always need to remember to update this. And the most automatic of all of them would probably be setting it manually to whatever your downward facing sprite is in code. So Sprite 3, because then if I decided to like make a new sprite and change it here, it would automatically be changed here. I'm going to leave it as this line of code personally, just because I like that. And yeah, so that should solve that problem. Like I said, sorry, I was supposed to remember to do that, but I didn't. But yeah, so for the rest of the video, this line of code will be missing, but we don't really mess with this anymore. So you're not really going to notice much of a difference. So let's just test that really quick, and it's working. There's a couple little quirks, like if you don't move, it always goes back to the right. The diagonals kind of always favor a certain direction, so you can do stuff like this, like weird goofy looking stuff. And our player is continuously animating even when they're not moving. Now 2 of those don't matter at all, at least in our game, right? We're just using the movement direction to test right now. We're not using it for the final. So the first 2 issues, the one where whenever we're not walking, we immediately face the right, that's because over here, when we are doing our movement direction, if we're not pressing any buttons, horizontal key and vertical key are both 0. You might have wondered about this whenever we did this earlier. What happens then? Well, technically, the movement direction, whenever you're going from 2 of the exact same coordinates, it's just going to return 0 because they're in the exact same space. So there is no relative direction between them. So the point direction function is just kind of default returning a value of 0, which is why it's making your character immediately go to the right. So that's why that's happening. And like I said, the reason that it's not going to be an issue is because we're not going to be using this for the final. And this also isn't going to be a problem where we're talking about the kind of weird going at diagonals for our 4 directional sprites, how it doesn't have like a nice priority or something like that, where the player faces the correct direction all the time. That doesn't matter either, because our movement direction is just returning increments of 45 degrees. That number will always just be rounded to either of the other 2 directions because it's always at 0.5 right in the middle. So again, that's why that doesn't matter. And the last thing with the animation, we can fix with a quick line of code. So let's add a line down here and call this just animate, or you could call it stop animating. Doesn't really matter. Same difference. And we can do this in a really easy way, where we can say the only time that we don't want the player's feet to be moving is whenever we're not moving at all, right? So if our X speed is equal to 0 and our Y speed is equal to 0, then we can force our image index to also be 0. So just a quick refresher on this stuff if you don't remember. I already did it up here, but the double equals sign is basically kind of like a question that goes along with the if. So a double equal sign is kind of like saying is equal to. So that's saying if X speed is equal to 0. You could also do it like this, if X speed equals 0, but it's just good form to kind of practice it this way. And then this is how you say and, so we're checking 2 different things. So if this is true and this is true, then we could run our code. Our image index is the frame that is being displayed on the animation, so we can just force it to be 0 anytime we're not moving. We don't actually need to stop the player from animating with the built-in variable called image speed. We don't need to mess with that because this achieves the exact same effect. And it also ensures that whenever we start moving again, our player animates. So let's at least check the animation one more time. So now we're not moving, Yep. So we're always facing, we go back to facing the right again, which looks goofy, but we do stop walking in place. Okay, great. So now let's move on to aiming our player at the mouse, which would be our reticle for some kind of weapon, right? So let's go back into our create event, and we're gonna add some more things under sprite control. Okay, so let's make some space above this stuff. The first variable that we're gonna want is our actual aiming direction. So aim dir equals 0 at default. This is gonna be the actual variable that we're gonna use to determine the way our player is facing, and we're gonna have to calculate it in a different way than we did with our movement direction. And the way that we're gonna calculate it is we're going to get the direction from our player's X and Y position to the mouse around it. And if you're thinking about where the player would be holding a weapon and holding and pointing the weapon, remember the origin of our player is right here at the feet. So the actual angle that we probably want is not from the feet to the mouse, but we probably want around the shoulders and the chest to the mouse. Maybe your character is a cool guy, shoot 'em cowboy. Maybe they're firing from the hip, something like that. The point is, you just need to think about where your character is actually aiming from. It's probably not the feet, regardless. I don't know, maybe in your science fiction post-apocalyptic game, everyone uses feet guns. Skateboards with feet guns. I don't know, that could be fun. If you make that game, please let me know so I can play it. But what I'm saying here is, for my character, and probably yours, we need like an offset amount. And as the game is running, we need to calculate sort of a center position Y for our player. So let's set up those variables. First, I'm going to set up the offset, so I'm going to call this center Y offset. And for my player, it was about -5 pixels, right? If I open up my player down, it would be about here. It'd be about -1, 2, 3, 4, 5, right here. Remember, it's minus because we're going upwards. When you go upwards on the y-axis, you're subtracting. So that's why it would be -5. So I'm going to make sure my origin is back in the right place. You can just go in the editor and you can count. You could drag it and count that way if you want to. Whatever, just make sure you put your origin back where your player's feet are or you're going to get weird results. So that's how I got my -5 number. And then we just want to calculate the center Y. And that is going to equal your current Y position plus your center Y offset. So it would be Y plus -5. And remember, your Y position can change at any point while your player's running around. So I'm just going to add a little note here, and we're going to say set in step event, because we're going to need to dynamically get this throughout the entire game. So this line of code needs to be repeated in your step event. So before we do that, I'm just going to highlight all this and press tab just to make sure we know it's all under sprite control. I can do the same thing for the movement variables. I think it makes everything just look a little bit cleaner. But anyways, now we can go about setting this in the step event and calculating this aim direction. So let's go into our step event. We can first region out our sprite control again, if you want to. And then we want to calculate this before we do our sprite control. So let's put it in between our sprite control and our movement. And we'll just call this player aiming. First thing I said, we need to put this back into the step event. So I'm going to copy it really quick. And I'm just going to paste it at the top here because we need this coordinate. And then next, we just want to actually get the aim. And you might know how to do this already. You might have figured it out. But let's just go through it. So we want to set our aim direction to, we can use our point direction function again, because we're doing two different coordinates. And what are those coordinates? Well, the first one is our player, right? So our player's X position and our player's center Y. Because again, we're not aiming from the feet. We want to aim from the shoulders. And then our second coordinate is going to be our mouse position, right? Well, luckily, GameMaker has two very nice built-in variables called mouse X and mouse Y. Mouse Y. Which just gets our mouse X and Y position in the room. Super, super easy. We have now gotten our aiming direction, and so now we need to go back into our sprite control, and instead of using our movement direction, we need to make sure we set our aiming direction. This is very important because if you don't do this, nothing will change. So yeah, we've changed our move direction to our aim direction here, and we got all the aiming done. So let's test it. And look at this. My player is now facing the mouse. So I can walk around the mouse and see, look at that. My player still faces it. And I can do this. Yep, look at that. Perfect. And we're animating and everything. Everything is peachy. Okay, once again, it's me from the future. I didn't actually forget this time, but I figured I probably should just go ahead and talk about it sooner rather than later, since I'm sure If you haven't done this kind of thing before, you're going to be a little bit curious. So if you notice, the player is getting drawn under our walls, and we don't really want that, obviously. That's where depth comes into play in GameMaker. Depth just kind of tells GameMaker the order at which objects should be drawn, right? You see this little graphic here, and you can see these 3 different things have different depth values, and you notice the one that's been drawn on top is the one with the lowest number. It's a negative number, and that's because that's just how it works. The closer you are to the camera, per se, in GameMaker, the more negative the depth is, the lower the depth is. Not necessarily negative, just lower. However, a really simple way to make sure that objects in kind of a fake 3D sense keep their depth at appropriate levels is you can do something like this. So we can add depth here, and we can say our depth equals our negative b-box bottom. Now you might have seen before depth equals negative y. That's basically the same exact thing because our bounding box bottom, which is b-box bottom, is the bottom of our collision mask, and our collision mask moves along with our x and y coordinates. So it's very similar. I just like to do it with this value instead of y. But yeah, so as the player moves up and downwards, the depth is kind of getting inversely affected by how far down the screen they're going. So the farther down the screen you go, the higher your y coordinate goes, which means the lower your negative y coordinate or bounding box bottom coordinate goes, which means closer to the camera, it's drawn first, all that kind of deal. So if you were to run the game again, your walls are probably just a positive depth from one of the layers in your room. So that means that anything with a negative depth will be shown over it. And this means that whenever we start adding enemies and other stuff later, your character automatically sorts itself out with everything else that is using code like this. So I was kind of holding off on that, but then I realized it probably wasn't necessary for me to hold off on it. I might as well do it now since people would probably be asking. So yeah, just know for a little while, I've recorded a lot. So just know that for a little while, this line of code is going to be missing on my screen, but that's just because I was doing it later. Okay, anyways, back to it. Okay, if you're getting anything weird, make sure that you're setting your center Y correctly, which really means make sure that you set your center Y offset correctly. So if you're getting weird results, just go back again. But anyways, we're now done with just getting the aiming. So that's all working perfectly good. And now is whenever we finally move on to the good stuff. Now we need to actually have something to aim and point. So in comes weaponry. We now have pretty much everything we need to draw our weapons. So now it's time to make your weapon sprite. So I'm gonna add mine back in and then I'll show it to you real quick. Okay, so here's mine. I called this S Blue Rod because my character is gonna use more like a magic rod type scenario. Okay, I think that's cooler. So you see it's got like a little magic orb on the end. It's got like a weird little ring around it floating. And it's got like a little grip on it because top and bottom orientation is important to factor in. So, you know, you can imagine this being like a gun like this or something like that, you know, something like that. But it's not a gun. It's a cool magical rod, which is much cooler. Sorry to say. It's just a cool magical rod where the little grip is at the bottom. So anyways, here's how I made my weapon. And you'll notice that I put the origin kind of at the middle of it and all the way to the left. That's because this is where we're going to want to pivot the weapon. We don't want it to spin around its center. We want it to spin around this point. So that's step one. Just make sure you've got something pretty similar here. Feel free to just do this. Feel free to just copy this. No judgment. That's how you learn. But now I have my weapon sprite, and now let's just go ahead and draw it. Just getting it on screen will be pretty easy, actually. So let's go into our player, and now we need to add a new event. We need to add the draw event. So draw event, just regular draw event. Open that up, and this is obviously the event where everything for the player is drawn on the screen. The draw event is like the step event. It runs every single frame of the game, but it's a little bit more expensive than the step event. It has more of a job to do because it can calculate things and it can also put things on the actual screen. When you don't have a draw event normally, it's basically doing this. It's not showing up, but it's basically doing this function called draw self, which basically just means do all the default stuff. Draw the sprite index and the correct image index at the correct X and Y built-in coordinates, all that kind of stuff. So go ahead and add this back in because you still want to draw your player. And we can even title it too. We can say draw the player, right? So add this back in because we don't want our player to disappear. And what we have right now is basically exactly what we had before, but now we can add more stuff. So I can add another thing called draw the weapon. And this is going to be super easy. Let's use this function called draw sprite. Not this one, draw sprite underscore ext. That's it's draw sprite extended. So this gives us more options to control drawing a sprite here, where normally the function draw sprite just asks us for a sprite to draw an image index and an X and Y coordinate. This adds a sprite, a sub image or image index, an XY, and we can change the scale, the rotation, and the color, and all that stuff. And obviously what we're looking for right now is that rotation. We want our weapon to rotate around the player. So let's draw our weapon sprite, which for me is S blue rod. I'm gonna draw the 0 image index, which is just the first image. Doesn't really matter for mine because there's only one image anyways, so drawing the first one works perfectly fine. We want to draw it at the player's X position, and we want to draw it at the player's center Y position. Remember, we don't want to draw it at player's feet. We have our X scale and our Y scale. So if we just make both of those 1, then it'll draw it exactly normally. It won't flip or stretch anything. And then we have our rotation, which obviously we want to make this our aiming direction, right? We want that to match the angle from our player to our mouse. And then we get our color. This is a color blending. So color blending is different than just drawing a full color. C white means that it's blending with white, which means it's blending with nothing. So C white will just draw our sprite exactly the same way as you would see it in the image editor. Then we have our alpha, which is the opacity, and we just want it to be fully visible, so we can just make that 1. It goes on a scale from 0 to 1, where 1 is completely like you see it in the sprite editor, and going down it fades out. So 0.5 would be half transparency, and 0 would be completely invisible. So that's all we need to actually draw it. Let's test that out real quick. And nice, we got it pivoting and turning around. It does look a little bit weird right now, and actually I'm gonna change my camera settings really quick. Okay, I just changed my window size to be a lot bigger so it would be easier for you guys to see, just because I realize this is a pretty zoomed out view. But yeah, so it's actually working. It should be drawing in the center of our body, or at least at the shoulder height, at the correct X position, even if we move around. Look at that. It's staying aiming at the mouse no matter what. So good. Okay, so couple issues. First of all, it is just drawing completely over top of the player. This is obviously not what we want. When we're pointing in the upper half here, we want the player to be on top and the weapon to be behind, right? And the reason that our weapon is drawing completely on top is because in our drawing code, it's done after the player. So the player is being drawn and then the weapon is being drawn, and that's what you visually get here. So that's problem number 1, the most noticeable one. The second one you might notice, especially if you have a bigger character, is the weapon is kind of glued to this point in the middle, where it should be kind of extended out to where the arms are. Or again, you might want to actually include the arms onto your weapon or rotate the arms how we're rotating the weapons. But the point is, even for my little tiny character, it still looks awkward. So the bottom shouldn't really be glued to that single point. It should probably be rotating in like this little arc, like where my mouse would be. That's probably where the butt of the weapon should be, in kind of this range, not just all right here. And then the final thing you might notice is pointing to the right looks totally fine in terms of where my grip is, but over here now it's upside down. And if you're making like a gun, for example, and it has like a handle on the bottom, this is probably very obvious that it's completely upside down, and probably looks even weirder than mine does. So we're going to solve all 3 of those issues, and we're going to do it in the reverse order of how I just said them, because as you can imagine, the most obvious looking problems are going to be the ones that take a little bit more finesse. So first, let's make sure that the weapon actually flips the correct way whenever we're going to the left. And basically what we want to do is we want to flip the Y scale. So let me just show you that in the room real quick. I'm going to create a layer where I can put sprites down, which is an asset layer. You don't have to do this, but this is just to show you. So here I have the weapon, and you can see I can pivot it just like I could in the game. And so if we're on the left side like this, what's happened is that our Y orientation needs to flip, right? So if we're over this point and over here, we can flip our Y. So our Y scale is normally 1. If we made it -1, you can see now that it's flipped the correct way. And if I were to rotate back, then it would be upside down now. So whenever we're on the right side, we want the Y scale to just be +1, and then we're on the left side, we want it to flip like this to -1. So easy. I'm gonna get rid of that layer and go back out here. Okay, cool. So we want to manipulate the Y scale, which is this argument right here. So first, let's add a local variable, and I'm just gonna call this weapon Y scale, like that. And at default, I'm gonna set it to 1, and I'm gonna plug it in over where our Y scale is. So this is exactly the same as what we had before, Y scale of 1. But now, before we actually draw the weapon, we can manipulate this variable first. So if we want it on the left side, we just have to do this. We would say if our aim direction is over 90 and our aim direction is less than 270, then that's when we want our weapon Y scale to be -1. So weapon Y scale equals -1, right? Because the left side would be 90 degrees is straight up and 270 degrees is straight down. So anything between those would be on the left side of the player. So that's when the weapon would flip its Y scale. So let's just test that real quick. And look at that. See, it flips down here and it flips up here. And so that way now it is always flipped the right way. Excellent. So real quick, I'm going to do what I've been doing and kind of tab out these groups so they look nice and segmented. And I'm going to comment this out and say flip the weapon upright. So cool. Our next issue was the fact that the butt of the weapon was kind of glued to the X and center Y position in the very center of the player, which didn't look very great. So we need to go back in our step event and we need to make another variable that'll help us out with this. So back to create, not the step event. And our new variable, I'm going to call this weapon offset dist. And I'm going to set this to 4. So this is going to be the number of pixels away that we sort of want our weapon to float off of the player. So again, this is going to vary for your own sprites. So I'm going to go to my my right facing sprite here, and you can see the length of the arm here is about 4 pixels. And so I want the end of the weapon to stop right here, to start right here and kind of pivot around. That's sort of the same with the downwards. You can see from here it's about 3 pixels down, but that's not too much of a difference. And then it'll be the same with the left and the up. So this is just the distance from this center point that I want the weapon to pivot around in a circle. So that's why I picked 4. If you're doing a similarly sized character, 4 might be fine. Just count yourself. If you're doing a big character, you're probably going to want a good bit bigger number. But now we have this. So now how do we use it? Well, let's add some stuff in here. And also another organization thing I want to do is I want to put this line down here. So I'm going to do that really quick. So I'm just going to cut that and put it here to keep it all organized in one thing. Okay, so I'm going to say get the weapon off the player's body. So let's make some more local variables. I'm going to call this var underscore. I'm going to call this x offset like this. And we're also going to do a Y offset, but let's do this one first. So we're actually going to use that really cool, handy length direction thing that we used to get our player's movement. Because remember, that helps us basically helps us find, like, you know, a perfect circle around an area because it calculates the length that we want and the distance that we want from a 0, 0 point. So let's use length dir x. The length we're obviously going to use is going to be our weapon offset distance, and the direction that we're going to use is obviously our aiming direction. We want the weapon to come off of the body in the direction that it's aiming. So that's the distance our X should be, and let's get the distance that our Y should be by doing the same thing, but this time using length dir Y. Remember, it's very important to make sure that you're using the correct one of these two functions for those different needs. Okay, they take the same distance, same direction, great. And now all we need to do is we just need to add these back to our X and Y's that we're doing down here. So X plus our X offset, center Y plus our Y offset, and that should do it. So let's test it out. Okay, yeah, look at that. And so now it's kind of like floating around in a circle. It's not glued to the actual arms. And you know what? I kind of like how it works on the right and the left, but I think it's a little off for the downward facing one. So I could either personally, I could reduce the weapon offset distance. I could kind of redraw the downward facing player sprite to have the arms go down a little bit more. Or I could just slightly move up my center Y offset. All of those things will kind of scoot up the bottom of where it floats around. And I think I might do this. I might add one more to this to make the center of the player go up a little bit more. Let me see if I like that. You know, yeah, I think that looks okay. It kind of hikes it up a little bit more on the sides, but you know what? Nah. I kind of like the original one. And like I said, I could do a couple other things to fix that, but this, my friends, is a magical rod, okay? It can float. It has magic. So that's what it's doing. It's floating, all right? Work smarter, not harder, you know what I'm saying? But anyways, you get the point. So we've got it working. And now we need to solve the issue of the weapon drawing always on top of the player. Sometimes we want it to be behind the player. So kind of like how we did here where we were checking, we were like, okay, if our aiming direction is above 90 and below 270, that means we need to flip it, right? To make it, you know, the weapon stay upright. We're basically going to do the same thing where we need to say if our aiming is above 0 degrees and lower than 180, which means we're aiming upwards, then we want to draw it here above the player's drawing function, so it appears behind and the player appears on top. And otherwise, if it's above 180 and below 360, we want to draw it down here. It'd be a little irresponsible to just copy and paste this code up here and then add the aiming direction checks in big blocks around each one. Mostly just because if you ever need to edit this block of code or add more to it or do anything more fancy, that means you're always going to have to change the block above you in the exact same way. And that can be very hard to remember and very hard to keep track of. It can be very hard to edit things when you don't remember which one you've been editing, especially if they get longer. So you'd be surprised down the line how difficult that would be to keep track of. But there is a way that we can do that super easily that's functionally exactly the same, but we won't ever have to edit 2 blocks of code or anything like that. We can create our own functions in GameMaker. So draw self is a function, length direction X and Y are functions, draw sprite extended is a function. Every of these orange yellow things, they're all functions. So there's something that you call, you maybe input some information for it, and maybe sometimes you don't, like draw self, you don't have to input any information, but it basically does a bunch of things inside of it by itself and then returns it for you. And we can actually make our own. So let's do that really quick. Let's go out here and let's right click and create, and we're going to create a script, which is just a code editor window where you can do things like create your own functions like this default one that came in. And you can also use it to set important pieces of data, like say global variables that you want to access from anywhere in the game. Because what happens is when you run a game in GameMaker, it runs through your scripts at the beginning of the game before it tries to run any other code. So that way it can check for stuff like any custom functions you've made. That way, the next time it sees your own custom functions in code, it actually knows what they are. So that's what a script is. I'm going to clear this out and I'm going to name this script over here. I'm just going to name this custom functions. Nothing fancy. Depends on how organized you want to be, but you can make any amount of functions that you want to in a single script. Doesn't really matter. So let's make a function here for drawing the player's weapon. And you saw the default thing that I already filled in whenever you made the script, but let's just go over that really quick, how you make a function. First, you just type in the keyword function. Then GameMaker knows that the next thing you're typing in is the function that you want to create. So now I'm going to create my own function, and it's going to be called draw my weapon. Then you want to set your parentheses like this to finish telling GameMaker that yes, this is going to be a function. And then you open up your curly brackets, and now anything that we do in here will be called anytime we call the draw my weapon function. And we actually already have this totally done. It's just in our player right now. So let's go into our player object. I'm going to copy the drawing the weapon line of code, go back to my custom functions, and I can just paste that in here. So great. Now all this code is inside of a function for the player to use in the draw event. Let's just prove that this works real quick. So let's go back to the player. And now instead of doing all this, we can just call draw my weapon. And we don't need to do any inputs for it. There are no arguments that it needs. It's going to be just like draw self. It just does all the code by itself, and that's it. So let's just make sure that's still working. And it is. It's totally identical to how it was before. Perfect. So now let's do what I was talking about. Now let's set up some checks to make sure we're drawing it at the right time. So if we're down here, if this code is being run below the player's drawing code, which means that this will draw on top of the player, that means we only want to do it whenever the weapon is being pointed downwards, which would be if our aiming direction was greater than or equal to 180 degrees and our aiming direction was less than 360 degrees. That's whenever we would draw the weapon on top of the player. So yeah, this is a greater than or equal to. That's how you would write something like that. And this is just a less than. You could also do less than or equal to is also something you can do in code. So easy peasy. You might be wondering why I've chosen a greater than or equal to here and just a less than here. I'll explain that in a second, but let's just go ahead and test this. So what should happen is whenever our mouse is below the player, it will draw the weapon, and whenever our mouse is above the player, it now won't draw it at all. So yep, no weapon, and there it goes. It's popping in. Great. So we've got it working at the bottom. And so now let's just say draw the weapon behind the player, and that we want to do if our aiming direction is just greater than or equal to 0 and our aiming direction is less than 180, then we can just again draw the weapon. So let's test that really quick. And look at that. Perfect. The kind of faux 3D effect is working perfectly. It draws in front of the player down here and behind the player up here. Now, the reason that we were doing the less thans or an equal to or greater thans and equal to and stuff like that, that is because if we only did like greater than 0 and greater than 180, what would happen here is if our aiming direction was at 0 degrees, it would actually pop out of existence and it wouldn't be drawing here or here, and same with the 180. If it has to be greater than 180 or less than 180 to draw, if you're holding it perfectly to the left, it would pop out of existence again. So adding these little equal signs here stops that from happening. And one more thing just to mention really quick is the function point direction, where we're getting our aim direction from and our move direction. It only returns numbers greater than and equal to 0 and less than 360, because once you're back to 360, you're back to 0. So we also couldn't do something like greater than 0 or less than or equal to 360, since aiming direction will never actually be 360 or greater. So this is how we need to do this. Easy peasy. And now anytime we want to mess with how we draw the weaponry, we just need to change it here in our function that we made for it, and it's automatically updated for both of these. So okay, we are officially done with all of the visual stuff that we needed to do before we could actually start doing any like gameplay. Okay, thank you so much for watching. It's pretty encouraging to get like a good looking player on screen, like walking around and actually controlling in some way. So yeah, it's pretty good. In the next one, we're gonna go ahead and get right to actually shooting projectiles and stuff like that. So one more step closer to having an actual game. So that'll be cool. And before I go, special thanks to my patrons on Patreon. You guys are absolutely the best. And I want to give a double extra special thanks to Nixionic, Red Dragon Redemption, Null, Joseph Sandlin, Midnight, Jericho Deloach, Mark, Augio, or Ayogio, and I'm just going to assume it falls somewhere on the spectrum in between those two, Homeless Bums Ahoy, and Skelenthrax. Thank you guys so much. I massively appreciate the support, and if you want to get your name read out or just on the screen here, then you know what to do. Just go to my Patreon. So yeah, anyways, see you next time.